Using Python. This is going to be a short tutorial for anybody who's completely new to using Python. I want to show you how you can make a start doing a few basic things without needing to install anything, without needing to download anything, without needing to pay for anything. We're going to begin by going to replit.com. That is replit.com. This is a browser environment for you to write code, and you can do it in lots of different languages, but we're going to have a look at how we use it with Python. When you first go to the website, you'll see a button that says Start Creating, and that will give you an option to sign in with various different accounts. So you can set up with your own email address, or you can join with Google, etc. You don't need to pay for this, although there is a premium version you can get if you want. Once you're there and you've logged in, you've signed up for an account, you'll be able to start creating bits of code. With the free version that you will probably use and that I use, you can't create code that is completely private. So bear in mind, anything you type into this could potentially be accessed by other people. The flip side of that is that lots of people have got code that they've written that you can find. So you can look through this, you can find code other people have written, you can modify it, adapt it for yourself. Once you're on this screen, I'll show you how you can start writing some code straight away. You need to look for a button that says Create REPL. It'll probably appear in a few different places. Your screen might look a bit different to mine because I've already logged in and made some things. When you hit that button, you might have some options come up for which language to type in. If you don't see it, then search for Python. And once you've got Python as the language you're going to use, the template, you can choose a title if you like. If not, you'll be given some random title, and that's also fine. Notice that this is by default going to be public. Anyone can view and fork this REPL. Fork means they take a copy. They don't modify yours. Yours will still be the same and saved in your area, but they can take a copy and then adapt it for themselves, creating sort of a new branch, if you like, based on the code that you've written. So hit the Create REPL button. And then we're going to jump straight in, and I'm going to demonstrate a few things for you simply by doing. So pay attention to what I'm writing and follow along for yourself. Maybe go back and pause and try these things for yourself to make sense of what's happening. The best way to learn to code is to actually code. So have a go at writing these things as you go, trying your own things, tweaking something and seeing what happens, and in particular, noticing when something breaks and trying to figure out why. Let's start with the most basic thing. We use a print statement. When we type print into this window on the left, whatever we write here is going to appear in the window on the right. You press the run button at the top and then the code will run. So until you press run, nothing happens. You can also use control and enter to do that more quickly. If you're in the middle of typing and you want to run something, control and enter and the code will run. At the moment, it does one thing and one thing only. It prints what we call a text string. This is a type of object that Python will recognize as just a sequence of characters. And even if it looked like something different, maybe you would recognize this as money, Python sees it as a sequence of characters. It's the pound sign, the 3 symbol, the dot, the 4, and the 5. So you couldn't really ask it to do things like multiply that by 2 in any sensible way. It's going to look at it as if it was a piece of text. And it's going to multiply the text by 2. So you can use that to your benefit if that's particularly what you want to do. But if you wanted it to understand that you were dealing with numbers, you can give it numbers to work with. You'll notice I'm using the star to represent multiplication. Python will recognize and use the standard order of operations. So when I do 4 times 2 add 5, it's not going to do 4 sevens unless I ask it to by giving it brackets. It's going to do 4 twos and then add the 5. So 4 times 2 add 5 is going to be different to 4 times brackets 2 add 5. Now you can leave extra spaces here. There's no particular reason why you need to or why you don't need to, but it might help the readability of your code. You can also add additional things called code comments. If you put a hash symbol, anything you type immediately after the hash on that line will be ignored by the computer, but it's something you can look back at to remind you about how things work. And it's something that you might leave as information for someone else who's going to come to your code later so that they understand the purpose behind some of the things you're writing. Now, we can use Python to do lots of fairly sophisticated calculations with integers. So maybe things that you would otherwise struggle to do by hand, 17 to the power of 20, for instance. It's a bit big for a calculator to work with, but Python has no problem whatsoever. You'll notice a double star is required for powers. So you might be thinking, oh, maybe I just use this symbol like I would in Google or Excel. But no, we need a double star to represent powers. 17 squared would be 17 star star 2. And 17 to the power of 300 might seem like it's a little big, but Python, again, will have no problem. It might take a beat, but it will write out the entire number for you, and it runs to like 7 lines. So it's a bit insane. Now, often when you're coding with Python, you won't necessarily want to print every single thing. In fact, there might be various steps to your calculation. And that's when it's going to be helpful to start using effectively a bit of algebra. So we can give letters or words values. We can say A equals 2, B equals 5, C equals minus 12. And then we can do calculations with those, A plus B. B squared minus 4 times A times C, and so on. So all of these calculations can come out, and Python will recognize when you use an A or a B that you are intending these numbers, 2, 5, minus 12, etc., to be used in place of those letters. If you didn't have these, if these were commented out, and this is a handy trick as well for the code comments, if you hold down Control and press the / key, which is also the same as the question mark, you can comment out a line of code or uncomment it. And that's a quick way to mean that the computer stops looking at it, but it doesn't disappear entirely, so you can get it back again. But you'll notice when we try to run this code, it has a problem straight away. It tells me the problem is on line 5. The problem is it doesn't know what A is. Name A is not defined. We've got to give A a name. As soon as we give A a name, it doesn't have that particular problem anymore. Now the problem is name B is not defined. So we give that one a name, and now it should be fine with line 5. It performs line 5, gives me the value of A plus B, but then it breaks when it gets to line 7 because it doesn't know what C is. So read the errors that come up, and that will help you to identify what's gone wrong with your code. You can go back and fix it. So for instance, if we're going to be making a bit of code that solves a quadratic equation, one nice way to do it would be to break it into pieces. We can use much longer and more descriptive names for our variables than just single letters. So we could say discriminant equals b squared minus 4 times a times c. One other thing to watch out for, Python will not understand 4ac written like this. Invalid decimal literal. It doesn't know what you're trying to write. It thinks it's some kind of number, so you'd have to do 4 times. But even this is not enough. It doesn't understand AC. Did you mean A? Because it recognizes A as something that's been defined and you've written something different. You can't just write AC, you have to write A times C. Now, I tried running this code, but nothing happened. At least nothing visible happened. What we're seeing here is Python has correctly stored the value 2 in a box labeled A, the value 5 in a box labeled B, and so on. And it's even stored the value of the discriminant in this box. And we know it was trying to, because remember, when I gave it something that it couldn't work with, it crashed. It had an error. So when I get to 4 times AC, it doesn't like it. But just because it's successfully performed the calculation on line 5 doesn't mean it's going to tell me about it unless I explicitly ask it to. One thing you might find from time to time, if this runs a little slow or it starts to crash, you can just go up to the top and refresh the page. You might notice also there is now a link at the top of the page. You could send that link to anybody and they could view your code and run the code without even logging in. And if they log in, then they can take your code, copy it into their own area with a quick click, and then they can start messing with it and modifying it for themselves. If I want to see what this looks like, I just need to use the print statement and I'll be able to view that thing as it comes out on the right. Any second now. 121. There we go. Now, if I want to use this code to actually solve the quadratic equation, I can use maybe x1 for the first solution and x2 for the second solution. The quadratic formula tells me I want negative b plus or minus. I'll use plus for the first solution. The square root of discriminant, and then all divided by 2 times a. So I put everything in brackets. And then the divide symbol is just a slash, 2 times a, also in brackets on the bottom, so it doesn't just divide by the 2 and then separately multiply by a. And then I probably want to print the value of x1. And we look for what potentially goes wrong this time. In this case, sqrt I used for square root. Now there's a couple of ways around this. One involves importing the math module, which you can look into in your own time if you like. But there's a lazy alternative for now, which will work just as well. Instead of the square root of as its own function, we could just use a power. Power of a half will do exactly the same job as square rooting a number. So now when we run that, the code should work fine. It'll give me one of the two solutions to my quadratic, 1.5. And I suppose you could test that out. You could try 2 times x1 squared plus, no, why 2? A times x1 squared plus b times x1 plus c. And this is a little test at the end to see if the value that you found for x1 for a possible solution to the quadratic really solves the quadratic. A times x squared add b times x add c should give 0. So it's not absolutely set in stone. We can't be 100% sure of this because just like any calculator, it is limited. It's not necessarily working in absolute values. As soon as you go beyond integers, you're raising things to the power of a half, you're going to get approximate values. But it looks pretty convincing. We've not made any big mistakes so far. Now, the second solution is going to be very similar to the first solution. So I'm going to use copy and paste. X2 is going to be almost identical code, but with a minus instead of a plus for that part. And then I want to print both of those solutions. And I start to get to the point where it's a little confusing because I've got lots of things appearing on the screen. And I can run my test for both of them as well. But now I don't know which of these are supposed to be the solutions and which are just verifying that my solutions are correct. It would be nice if we could format the answers in a way that will be a little more convenient for the person using this machine. So I'm going to introduce something called an F string. We use a lowercase f followed by speech marks, and then we can write what we want. So for instance, solutions. Then we close speech marks at the end. Let me get rid of this line. At the moment, nothing different is going to happen. It's just going to show me solutions and then unhelpfully x1. But if I enclose x1 in what's called a replacement field, with these little curly braces that you can find just to the right of the P, Shift and the square brackets button should find those for you. Now, when Python sees those curly brackets, it's going to replace whatever's inside by whatever you get when you ask Python about this thing. So for instance, if you say 3 times 4, it'll evaluate that and say 12. And if you say x1, it'll recognize that what you care about is the result of calculating x1, which it already has. So we could put a comma in there and then put x2. That way we've got a much more convenient way of writing the solutions, and it's clear to the user what the two solutions are. And then we see if we can break the code. So for instance, if we had 1x squared add 2x add 1, I think there's one repeated root to that one. So we get the same solution twice. Although this isn't necessarily a problem, it might be useful to have something different happen when the two solutions are the same. So we might have something like if x1 is equal to x2, then we just print something that says repeated solution, and we just print x1. It's the same as x2, so it makes no difference. Otherwise, so we use else, we print both. This is what's known as a conditional statement. It happens if something is the case. And we've got a test in here. You'll notice something a little bit weird. We've used an equals sign a bunch of places before. This time we've used a double equals sign. There is a difference. Up here, when we use a equals 1, It's a bit like saying let A be equal to 1, or equivalently, something like define B to have the value 2. That's what we mean when we use a single equals sign. It's using the equals sign as an assignment operator. It is assigning a value to a variable. We did the same thing with discriminant. Discriminant is a new name that Python's not seen before, and we're going to assign a value to it. You can overwrite these things. So if I decided that I was going to say discriminant actually equals fish, and then I said, actually, no, discriminant is going to be this after all. It's not going to break our code. Everything still works fine. Because although discriminant was briefly just a label for the data fish, suddenly it's been overwritten and replaced by this new thing. Most programming languages won't let you write something as a text string and then replace it with an integer straight away, but Python's a little more flexible when it comes to the type of the data you're dealing with. So you can overwrite things using the assignment operator equals, but when we get to this one, this is a comparison operator. Double equals is a comparison. We're basically saying x1 is equal to x2. And that may be true or it may be false. And in this case, we're using the truth or false of that statement to change what the program does. If x1 and x2 are actually the same as each other, as in this case, then we're going to say there's a repeated solution. Otherwise, in the case when that isn't true, we're going to do something different. There's one other thing to notice here, and that is the indentation. After I wrote if something, I put a colon, I pressed enter, and the cursor jumped a little bit before I wrote the next statement. We can test this out. If 3 is equal to 4, colon, press enter, and I'm indented slightly. The reason for that is that anything that happens within this indented block is what will be carried out by the program in the case when 3 is equal to 4. And if I put else, then I can put whatever else I want to happen if that is not the case. So when I run this program, 3 isn't 4, predictably. Now, I don't need the else statement. I could have just this bit. And then if 3 is not 4, then everything's fine, but nothing gets done. This isn't printed. If, on the other hand, I have something else, both of those things will happen only in the case when this statement holds. Now, if I said 3 is not equal to 4, both of those things are, well, this thing is true, 3 is not equal to 4, exclamation mark followed by an equal sign, not equal to, and therefore both of those statements are printed. Notice what happens if I unindent this. First of all, you won't see anything changed first time through. But if suddenly this goes back to being 3 is equal to 4, well, 3 isn't 4, so this statement doesn't happen. But the next statement still gets written. And that's because it wasn't indented the same as the line above. Line 20 is on the same level as line 18. So after the if statement has happened, line 20 is going to happen regardless of whether 3 was equal to 4 or not. So that's what's happened here. The indenting means that this print statement happens only if x1 and x2 are equal. And then within the else block that follows, this statement only happens if x1 and x2 are not equal. There's one other thing that could happen, a bit of a weird edge case. If we have x squared add 2x add 10, we get some very funky results. This is similar to what will happen on your ClassWiz calculator if you ask it to solve a quadratic that has no solutions. Technically, your quadratic might have solutions, but they might be complex solutions, imaginary numbers or something like that. And that's what we're looking at here. solutions which are not real and therefore require an I or a J, which is an imaginary number that you might learn about if you do A-level further maths or something in due course. But that's not something that's particularly helpful if we care about, are there solutions? Are there actual physical places where the graph crosses the axis? Is there a point in time when the rugby ball reaches a height of 5 meters? And if there isn't a real moment in time when that happens, I just want to know that. I want to know, no, there are no solutions. The missile will not reach the destination, or whatever it might be that we're calculating. So I need a little test for that. Luckily, that's exactly what the discriminant is for. The discriminant is designed to do that test. So we can break down our test at the very beginning. We can say if the discriminant is less than 0, we can just print the statement, no real solutions. There are no real numbers that make this true. And everything else needs to go inside the following block. So we would need to grab all of this, highlight it all, and then you can just press tab one time and the whole thing will be indented to the appropriate degree. I'm going to bring this up a little bit so we can see what's happening. And now you'll notice even the if statement that happened inside here, there is some double indentation going on, because this if problem only happens if we're within this else block. So now if we run it, the code will reach this point, test to see if the discriminant is negative. If it is, they'll say there are no real solutions, and then it stops. Nothing else happens. Only if that's not the case do we go on to do the next bit. There are a couple of other ways to run this. We can, for instance, bring in a test. If the discriminant's less than 0, then this happens. What if the discriminant's more than 0? Then we'll need 2 different solutions, and we don't need to do the test for a repeated root. And if the discriminant is exactly equal to 0, we only need one of these. So there's a few different ways you can run this and set up your code. But hopefully that's given you a bit of a flavor for how you can write a program in Python. Usually, particularly when we're getting started, the input from the user might simply be assigning values to some variables at the beginning. If you've got anything that's less obvious than the A, B, and C from a standard quadratic, then it might be worth giving the variables names that are more descriptive. So potentially, particularly as a mathematician, you can get away with some fairly brief names for variables, x1, x2, a, b, c. But if you've got something that you're trying to describe to someone else who's going to read your code, it's going to be helpful to use proper words for it. So hypotenuse, adjacent, etc. You can use big, long words. And if you want to string words together in Python, you can do that as well. So you just have to do it without spaces. So second root, rather than x1, x2, you could use words for those, and it might be more descriptive to whoever's reading your code.